Welcome to The Explainer. So today we're going to break down the foundational language of data science. It's all about understanding uncertainty, how we turn what looks like random noise into actual predictive insight.
All right, so let's jump right in. But first, to really get a grip on this, we need to talk about the world we're living in right now. And honestly, it's a world that's defined by a truly massive number. Get this. We are generating 2.5 quintillion bytes of data every single day. I mean, that's a 25 followed by 17 zeros. It's just mind-boggling, right? And a huge driver behind this data explosion is something you've probably heard of, the Internet of Things, or IoT. You know, that's the whole network of everyday stuff from your smartwatch to your smart fridge, all connected to the internet.
I mean, it wasn't that long ago that we were storing tiny bits of data on floppy disks. Remember those? And now? Now, our cars, our TVs, even our coffee machines, they're all online, all talking to each other all the time, creating this just unimaginable flood of data. So with this much information flying around, the old ways of looking at data, they just don't cut it anymore. I mean, the sheer volume, the complexity, it creates a ton of uncertainty.
And that is exactly where data science steps in. See, at its very core, data science is all about using the language of probability and statistics to slice right through all that uncertainty. It's how we manage and make sense of the data, and ultimately, how we make some pretty powerful predictions. So if you want to think like a data scientist, you gotta speak the language, right? So let's get into the three fundamental terms that are basically the building blocks of probability. Okay, first up, a random experiment. Now, this is basically any process where we just can't know the exact result before it happens. Think about it, flipping a coin, rolling a die, even trying to predict what the stock market's gonna do tomorrow. If the outcome isn't a sure thing, well, that's a random experiment. Second, we have the sample space. And this is super simple. It's just a complete list of every single possible thing that could happen in that experiment. So for that coin flip, your sample space is just heads, tails. For a standard die roll, it's 1, 2, 3, 4, 5, 6. It's the whole menu of possibilities. And third, there's the event. Now, this is the specific outcome, or maybe a bunch of outcomes, that we're actually interested in. So if our experiment is flipping that coin, the event we might be looking for is getting heads. If we're rolling a die, our event could be something like rolling a number greater than 4. It's what we're watching for. So let's put it all together with that classic die rolling example. The random experiment, that's the act of rolling the die. The sample space, that's all the possible numbers, 1 through 6. And the event, that's the result we care about, like, say, getting a 2. See, it's that simple. Experiment, sample space, event. Those are the big three. Okay, but here's where this gets really, really powerful. This simple little framework, it's not just for board games. Nope. It is the absolute foundation for solving incredibly complex real-world problems. I mean, just look at this. Predicting if a big sports match will be played because of the weather, that sounds super complicated, right? But check it out. It uses the exact same logic as rolling a die. The experiment is the prediction itself. The sample space is super simple. Either the match is played or it's not played. And the event we care about? The match is played. It's the same structure. And this, right here, is the key takeaway. Some of the most advanced data science applications that you and I use every single day, think about Netflix's recommendation engine or how Walmart manages its entire supply chain. They're all built on these surprisingly simple, really intuitive ideas. So here's the bottom line. Once you really get this core language, you suddenly have the power to start making sense of a world that is just full of uncertainty. And that leaves you with a really fascinating question, doesn't it? If a simple die roll and a complex weather model are built on the same foundation, what other crazy uncertain parts of our world can we start to measure? And maybe, just maybe, even predict?